Welcome to the first session of the Cloud Computing and Big Data Laboratory. So we're starting with the laboratory instead of the course. First of all, I'm going to introduce myself. I am Genoveva Vargas Solar. I am Principal Scientist of the French Council of Scientific Research in the LIS lab, which is located in Lyon, in the southeast of France. So as you have seen at the beginning of, once you logged in, we have 7 hours difference. So this is something that we will have to take into account if at some point we organize some face-to-face interaction for the course. Other details about myself, you can Google me and then you will find what I'm doing. I'm I'm a database specialist, and I work on data science, on cloud computing since some years ago, and I address these aspects, particularly graph-oriented data on different high-performance computing architectures. So this is in general what I do. I am not a faculty member, so my duties are only devoted to research, but I am very happy to have the experience with you during this spring term to interact and see what we can do in the practical aspect regarding cloud computing and big data. So today I'm going to devote the session in order to, of course, introduce the topic, but also in order to define the methodology of work that we are going to adopt for this laboratory. It's a kind of sui generis way of working, but I think that the idea from my point of view is that to create an environment that you will normally have to face if you are working in your professional experience in big companies where people are distributed, where you have to use different communication channels and different strategies in order to interact with people and develop solutions. So this is the kind of environment that I am going to use in order to interact with you and let you have a little bit of experience in such kind of environment. This is why I'm going to devote this session in order to organize things so that to make sure that everyone will be on the same page and that we will all work together in an easy manner and smooth manner. So first of all, I am going to introduce, more or less, to motivate the idea of the laboratory. Well, when we talk, there are 2 elements you have seen in the title. One element is data, and the other element is cloud computing. So I'm going to try to motivate why they can be put together and what are the challenges that we will be facing in this laboratory. So the thing is, with big data is a little bit old term today. It has been around for many years, and the idea behind this buzzword that some years ago is that in fact data is all around, and that today many systems, many devices are producing huge volumes of data. And it is not, from the computing science point of view, it is not that we are kind of anxious about having too much data. We are used to deal with big volumes of data. But the thing is that in the last years, what has happened is that the access to this data and the needs for processing and exploiting the data has moved from circles, very small circles, into a democratic environment. So anyone can have access to this data and would like to exploit this data. And this change of the cursor between having data consumed by institutions, by scientific institutions, by the banks, by organizations like that, and moving it to normal citizens has introduced an enormous challenge, which is let people access and exploit the data in a very transparent manner. And us, as computer scientists, we have to make sure that the systems that we design and the solutions that we design cope to these prompts, these transparency prompts. And well, since we like to develop computing solutions, so it's a very interesting and challenging objective. There have been some technological milestones that have led and have opened the possibility of developing such kind of solutions. One that has been around for a long time ago, it's the Web 2.0, that I'm sure that you have already had the experience to develop systems on top of it. So as you can see, the idea is that you have these open platforms, these environments that ease and make it possible to develop computing systems based on data collections and accessible to anyone. And the example is that today anyone has on his or her device applications dealing with data, and we have watches and we have many devices where we deal with data in a very transparent manner. An element that is behind this data all around is the volumes of data that computing systems are able to deal with. Because this is the starting point where the notion of big data acquired its importance, and as I said, some years ago. So we have been moving through the history of computing science from what we call always big volumes of data. Well, you are too young to remember. Even me, I would say that I'm still young to remember, but we have to recall that the humanity was able to reach the moon with systems dealing with 64K. 64K today is nothing. Okay, so the idea is that anyway, we have been moving through different volumes of data. And just to motivate the idea of these different volumes of data, you have to remember that, for example, using, if we consider bytes, which are today very small volumes of data, 8 bytes is enough information to create an English letter or a number in a computer code. Then we reached megabytes, and for example, from the complete works of Shakespeare can hold in 5 megabytes. Okay. Then we have moved, and for example, today anyone in his or her living room has a disk sitting to deal with personal data, and we have terabytes of data. We have computers with terabytes of space. So what can we do with terabytes? Well, all the catalog books of the American Library of the Congress is a total of 15 terabytes, okay? So in your case, of course, this is not surprising because as I said, we have hard disks sitting in our homes with much more or some terabytes in order to deal with our personal information. Then we can move towards more volume, and we can talk about petabytes. Petabytes is 2 to the 50 bytes. For example, all the letters delivered in the America's Postal Service this year, the year I'm talking there is 5 years ago. Okay, so in that time, the year was 5 petabytes, and Google processed 5 years ago around 1 petabyte per hour. Okay. And then again, we can move and we can talk about exabytes, so 2 to the 60, the equivalent to 10 billion copies of The Economist, the journal, holds in exabytes of space. And then we can talk about zettabytes. Zettabytes, for example, is the total amount of information in existence this year to forecast climate aspects, and this is 1,27 zettabytes. And then we reach to more delicate volumes of data. We can still talk about jottabytes, so 2 to the 80. And for example, 5 years ago, this was too big to imagine. Today, it is possible to deal with such amount of data. So as you can see, we have been moving all around the history of computing science through these volumes of data. And at every time that we reach to a kind of limit, what has been the problem? Well, the problem or the challenge that we have to face is invent architectures, storage and computing architectures that can process such amounts of data in reasonable response times. Okay, and when you talk about reasonable response time, something important that comes to the arena is the type of applications that will be sitting on top of these of the processing of such volumes of data. And their applications have their importance because they have expectations with respect to the performance that has to be ensured in order to deal with such volumes. So there is computing architectures, and there is smart processing strategies in order to exploit computing resources in order to build, to exploit such volumes of data. Even if with 8 bytes or with jottabytes, the problem is always the same. How to provide computing resources in order to process a specific volume of data and cope with the expectations of applications, and particularly in terms of response time. And there, as I said, different applications have different expectations. If you are an astronomist working, willing to deal, for example, with the observation of half of the globe, you can expect that some of the processes that you want to perform, you would like to, you can accept to wait for some days in order to achieve your results. But if you are running the stock exchange, you cannot wait for days. You need to, in terms of seconds or milliseconds, to have data processed in order to make decisions. So you see different expectations, but always from our point of view, how to deal with resources in order to process such volumes of data in a specific time, performance time. Okay. So as I said, well, applications, once you have data and once you have computing resources, applications move on, okay? They evolve. And so at the beginning of the history of computing science, when we talked about volumes, huge volumes of data, there were experimental sciences, particularly, that were our clients. fields. Okay, so we're talking about astronomy, biology, chemistry, this type of sciences were used and are still using computing resources in order to run their models. Then there is also theoretical science, computational science, but then at some point there was the data-intensive sciences that were normal clients of this type of requirements. As I said at the beginning of the session, then this slide doesn't show that, but then it moved to day-by-day applications that we are now used to run. Now, if we go if we will zoom in into the problems that we as computing systems engineers have to address in order to play in this arena, there is a problem, of course, of data management. Okay, of course, there is a problem of computing resources management that has to support data management. And this is what we are going to play with in the laboratory. We are going to see, once you have some specific data management problems, how to inject computing resources so that the management of your data and the exploitation of your data will perform correctly with respect to the expectations of a specific application, okay? So how do we state the problem of this data management at scale? Well, the thing is that I started describing that there is the aspect of data volume that you can see on the left of the figure. And so there you have different scales where we are going to be moving around. Note that I am starting at the level of petabytes, because normally in this laboratory, we will be talking of important scales, okay? Everything that can be done in a normal computer does not interest us, okay? We are moving to huge environments with many resources where we have to, the challenge to, as I said, to inject resources in order to play with the data, okay? So you have the data volume, and then you have, of course, the necessary hardware in order to deal with the data. An important thing that we all have to consider is that, of course, no such volume of data, it will be possible to handle it in one disk. Okay, so we are going to move from normal disks into RAIDs and into clusters of RAIDs that can hold huge volumes of data. And what is the problem if we talked about these two dimensions? Well, the problem is that we have to figure out which are the right strategies in order to organize the data in this playground, and then such that when we retrieve the data, when we update the data, we can go fast, okay? Because one thing that it's important when we talk about data is that the overhead of the data management does not have to impact, or the impact should be very small with respect to the whole performance of an application. So there we have to have the right strategies in order to organize it perfectly so that we can guarantee that the data will be there when processes will be using it, okay? And then, of course, in the other dimension, you have applications. Of course, now we have the right applications that are normal clients of such requirements. So we have applications that are reactive, that run in real time, that are ubiquitous, and that normally are adaptable. They move from the watch to the phone, to the computer, and to the high performance computing center. Okay, so this spectrum of requirements is there. And so, as I said, as computing systems engineers, we have to choose the right hardware with respect to the volume of the data in order to respond to our application requirements. And this is the game, okay, that we will be playing in this laboratory. Well, of course, I'm going to remind this because it's important to be sure that we are talking about the same things. I remind you that when we are talking about resources feeding to processes, we are talking about memory and computing capacities, and of course storage. And when we talk about memory, we are talking about main memory management. And when we are talking about computing capacity, we are talking about CPU cycles, and then storage. Storage is an important thing to clarify. It's not only the hard disk, it is cache, and it is main memory, okay? So storage runs around these 3 levels of the stack, and the strategies must be considered, and the resources that you are going to feed in order to process the data have to consider these 3 elements, okay? And this is what makes the problem interesting. So, of course, if I'm saying that we have to deal with this problem, an important element that we will study in the lab is how to move around different computing architectures. I believe, I am not sure about the type of profile that you have acquired during your studies, but I believe that in general, you have been playing with, I mean, centralized in the sense that everything runs on your computer, or you use servers in client server settings in order to run your applications, but the clients and the servers are normal computers, okay? With, of course, now we have computers with different cores, etc., but they are kind of classic architectures. I'm not sure, but I would be surprised if you have used mainframes, for example, in order to run the applications that you have been studying. So this is a very interesting way to start when we start building applications, because many applications are happy if they run correctly in this kind of setting. But the thing is that if we are moving to more important scales and more important requirements, we have to go from out of the box, and then we have to think about other architectures that are there and that are well adapted when we want to scale solutions. Okay, so we are moving into, of course, distribution. I believe that you have already had a distributed computing course, but now we are moving to the wild. Okay, so to settings where, for example, you have architectures where you have to adopt new programming models in order to exploit the architecture, okay? So I'm talking about high performance computing architectures where you need to move to other well-adapted programming models in order to exploit all this, okay? So this is the way we are going to move into the cloud. We are going to see different architectures. We will start with the notion of cluster, for example, so putting together different computers in order to extend computing capacities in the terms that I have defined in the previous moment. So how do I get to extend my main memory in order to run greedy algorithms, for example? How do I adopt different caching strategies where the cache is distributed around a specific architecture in order to fetch data and to prepare the data so that a program can have the illusion that it is consuming data continuously, where this is not the case, where data is coming out of different distributed disks and it's moving to cache and then to main memory. This kind of new ways of thinking, because we have more resources and different architectures that we have to deal with in order to develop the right solutions, okay? And then of course there is the CPU cycles. How do I ask the operating system to give me and to allocate to me the right computing cycle so that my program can run in a smoothly manner, okay? So there are architectures that run in these kind of conditions. And so the idea in the lab is to show you these different architectures and how the programming models should be modified together with the data management strategies in order to exploit correctly these architectures and provide good services by our designed and programmed systems. And well, today I will not touch too much the kind of applications that are there to exploit all these, but of course you are not living in an independent environment, so you all know that today new aspects of new programs and new algorithms associated to artificial intelligence are those that are consuming this type of architectures. We will have different examples in our exercises that will touch these aspects, because these are straightforward clients that really need to be running this type of architectures, and they are good examples. But here, anyway, in the slide, there is the artificial intelligence aspect. What we will be interested in this laboratory with respect to cloud and big data is the algorithms that sometimes are proposed by the artificial intelligence discipline, okay? But for us, if it comes from the artificial intelligence or any other discipline, it's not important. What is important is the characteristic of the algorithm and how we are going to deploy it in a specific architecture running with a lot of data. Okay? That will be the case. So no need to be acquainted with the artificial intelligence algorithms in order to be able to run to make good in the laboratory. This is they are just examples. Okay, so across the different architectures that we are going to be dealing with, of course, mainframes were around in the 60s. Then cluster computing emerged it's a quite old solution. It's the 80s, but it's still all around. And we are going to touch exercises in order to get you acquainted with how to organize clusters and how they look like and how to exploit them. So that's even if it's a kind of old architecture, if you want, it is important that you get acquainted with that. Then in the 90s emerged like a kind of scale version of cluster computing, which was called the grid computing. Grids were very popular in experimental sciences. For example, the CERN, the Physics Institute here in Geneva, they have used this grid computing in order to run their huge processes. And in many different organizations where the experimental sciences had to run processes, they adopted the grid computing architectures. Even today, for example, in the context of smart energy, in smart energy applications, the back end of these solutions is grid computing, okay, and smart grids. So we will touch this more in for your education, much more than with examples, because we will then move, and that will be the focus of the laboratory. We will be playing with the cloud, which is a very nice evolution of all these architectures, with specific properties that let us get rid of the difficulty of course, of accessing a computing system, like adopting a grid architecture, but so we all can access the cloud. And also as a very practical evolution that of the architectures that ensures also a lot of time to market in order to build systems. Okay, so the cloud appeared around 2007. It's been around for a long time. So for your professional career, it is very important that you get acquainted with cloud architectures. You know which are the right providers, you know how they work, what are the criteria in order to build solutions in such environments, because in the professional life, you will certainly have to deal with the cloud. Okay, so it's really, really important that you understand perfectly how does it work, beyond the common places that we listen on TV or in other media. You as computing systems engineers, you have to be clear of what it is, how to use it, and in which conditions to use it in order to provide good solutions in terms of computing systems. Okay, so this is a big panorama of what we will be addressing in a very clear, I hope, and correct manner. I am going to give now some, well, I'm going to stop a little bit to see if you have questions, and the next part of the session will be devoted to explain how we are going to work, the objective of the lab, the content, etc. Because for those that arrived a little bit late, it will be a kind of different way of working together. So I just want to make sure that for everyone, the methodology is clear, so that we can work nicely during the semester. So before I continue, I can open the floor and let you ask questions if you have. For those that arrived late, if you do not feel comfortable opening your microphone, you can use the chat, and I can read it. I will read your question. There is also a Slack channel. We will go for it in some minutes. You can also use the Slack channel in order to ask your questions, or you can feel free and open the mic. If you do not feel comfortable because we are recording, let me know. I will stop the recording. You can ask and you can interact, and then I start the recording again. So questions? Okay, if there are no questions for
no
the,
questions,
yes,
teacher. Well,
yes, go ahead. Hi.
no questions, teacher. Hi. Good to meet you. No questions. Just excited to learn, to be honest, because it's a new technology that I always see, but I do not understand. So very
Okay.
excited to start.
Very nice. Yes. Um, just to, well, I don't know exactly what you have addressed. Now I only know that you are at the end of the career. That's right. No, you are in the last semesters of the. This is your last semester, in fact. Is
Yes.
it the
Yes.
case? Okay. Okay. So. For that, have you had a parallel computing course?
No, no.
Okay, okay, okay. So this means that because in parallel computing, normally there you use clusters and things like that. But okay, so you haven't had this kind of experience. So that's much more exciting because I mean, once you have acquired, I mean, an advanced knowledge of computing and programming, etc., then moving to new ways of organizing your programs and running them, it's quite interesting. And it's also kind of interesting for a professor because you do not have to, you know, like learning how to write. People know how to write and how to program, and you go towards more interesting problems to address. And this is also very exciting. Yes, thank you. Okay, so let's move to the kind of organizational aspects. So first, the lab. The lab is a playground. Okay, so we are going to play a lot, as much as we can. And the idea is to test and develop solutions for managing and processing data on cloud architectures. You will see that today there are many vendors. I'm going to try to show you different examples of vendors so that you have the different feeling and that together we can discuss and compare which you find more accessible, which is powerful, but you have the feeling that you need more skills in order to know how to use it. See, so the different proposals that vendors have and what you can expect out of them. So this is why it is important really to be ready to play, to explore, and in order to get the full experience, okay? So it's like starting over again, okay? Because everything that you have learned about data structures, about programming, about algorithms is back into the man, okay? And the difference is that we are going to wrap up all these things together and see how does it look like to apply all these in a different context. Okay, so we were on Earth, playing on Earth, and now we're moving to the moon, and there's no gravity, and now we have to see how do our programs work when there's no gravity. Okay, it's like kind of the metaphor that I can use in order to explain in advance the idea of this experience. And another important experience we will see when we will start touching the fundamental concepts of the cloud is that I'm sure that you remember when you had your algorithmic courses that you have to estimate the cost of your algorithms in terms of cycles of cycles of CPU, and then on memory usage. Okay, but beyond that, I mean, beyond knowing whether an algorithm could run on top of your computer or not, there was no harm. Okay, you will see that when the cloud appeared, it was the first time that economic issues came into the matter, because using resources has an economic cost. in the cloud. So before we put the credit card and we go to use them, we have to figure out how much our solutions cost so that we can make sure that it's economically viable to put them on the cloud. Okay, and this is a huge difference because normally we never think about that. Of course, we pay our internet and we pay our devices connection, and we know that we have to make sure that we do not keep playing or sending mails or whatever in our communication channels because our subscriptions are limited. Okay, but now it's everything, anything that we will do in our applications has an economic cost and we have to be aware of it. Okay, so that's quite an enormous difference with respect to what we normally do when we develop solutions. So that's something that we will see constantly in the different exercises that we are going to perform. So, and that's a kind of challenging aspect of this game. Okay, now what is the objective? Well, the objective is to develop advanced computing systems. Okay, so now you are at the end of your studies. You have had enormous experiences in doing many things, and the idea is that now we go for advanced challenges with respect to what you have been doing during your studies. Okay, and as I said, we're going to combine hardware management with data management. And this is a kind of exciting thing to do because normally, particularly if you have been using DBMS and such kind of systems, these systems do the work for us. Okay, and now there is no DBMS, or even if there is, we have to figure out the right strategies, and this is quite challenging, but also very exciting. So this is the context in which we are going to move the different exercises that we will run during the lab. Now, in general, the content. So in some minutes, I will tell you where you find the syllabus and the material and everything, okay? But I'm going to present the content in order to present the syllabus. So it's kind of simple, even if it's not simple, okay? So first of all, we have to get acquainted with the reference architectures of the clouds, okay? So we are going to talk about those things. And as I said, the idea is that you touch things. So in order to see how these concepts look like in different clouds, we will use them so that we see how you go from theory into practice. Okay. And of course, now today you saw that the cloud emerged in 2007. We are in 2022. So at the moment when it emerged, there was only one economic model, business model associated to the cloud, which is called pay-as-you-go. Today, there are different models, so we will see which are those models and how to adopt them and how to consider them in order to design our application. So that's that will be the first part of the laboratory. It's like preparing your running environment. Okay, so this is what we're going to do. We are going to prepare the running environment on top of which we are going to deploy our solutions. Okay, so this is the first part of the laboratory. Then, as I said at the beginning of the session, well, there is the problem of organizing the data. Okay, so once you have a lot of data, you have different solutions today with different properties and different characteristics. None of them is better than the other. It's just that you have to make sure that you understand their properties and their guarantees, and you adopt the one according to what you expect. Okay, and what are the properties, functional and non-functional properties that you want to ensure, and according to this, you will choose the right technology. Okay, so we will see which is such a technology. It goes from distributed file systems towards data management systems adapted to cloud context, and so we will see how they work. This will be the second part of the laboratory. I'm here. Then comes the great thing to do, which is changing programming models. And the way it changes is that we have been working in what we call a centralized sequential programming model. And so we will move to a parallel programming model that is very popular in cloud architectures. Of course, we are not in a parallel computing course, so we will touch parallelism like in a horizontal manner. But anyway, we will get acquainted to two strategies that are those that are today used in order to process data on cloud architectures, on high performance architectures, which is one that is called MapReduce. And another MapReduce is an imperative solution, and then we have another which is a data flow solution. So we will see again both of them because I'm sure that you will see them in once you will go out in the professional life. So this will be the second part of the laboratory. Then, well, the cloud is over there somewhere, but how do we touch it in order to work with it? Well, it is based on virtualization. So the way, the kind of exchange of resources in order to access the cloud is virtualization. And there are many techniques of virtualization. And so the idea is that we have to introduce and to see such techniques because these are those, it's like if you are designing a product, you have your product that runs in a specific environment, and you have to create a package that you will use in order to deliver your solution. This virtualization is kind of the package that you are going to adopt in order to deliver your solutions, okay? And so the idea is that you have again to decide which is the right package for the product that you are going to develop. So this will be the part of virtualization techniques. And then we will go towards, as I said, let's go to the wild. Like when you ski, you go either through the right roads, the ones that anyone use, and then you go out of the road and you go to the wild and see what happens. So this will be the fourth part, which is really doing and developing some examples of solutions, mostly related to data science, and see how they work and how they are maintained and how to deal with different aspects of their maintenance and their execution in cloud virtual machines. Okay, so that will be, this is the menu of the lab that as I said, we will run during this term. Now, the methodology. Well, there is a huge aspect of content management. There is an external site that I have prepared. I'm going to, how to do this? Well, I'm going to wait a little bit. I'm going to put the link in the chat so that you can go and see. I will show you the site in a minute. So there is a site where you have the content of the associated theory course and the lab, and there you will have everything available, okay? The slides, the exercises, all the things that we are going to produce in terms of content, of I mean, textual content, if you wish, will be there. But I also know that the university uses Blackboard in order to deal with all things and around the course. So I'm going to have a copy of it. The reason that I will have a copy of it is that I'm not member of the faculty. So I like to make sure that I have the full control of what I provide the students. So I will use the Blackboard. It will be like a mirror of the site modulo the grades that will be only on the Blackboard. You will not, no, the grades will not be out of in the internet available to everyone. Okay, they will be managed on Blackboard, but any other content will be managed both on Blackboard and on the site. So do not get anxious of going to the two environments. Once I will have access to Blackboard, I will put everything on the Blackboard, and then you have your normal environment there. So about the content, okay? There will be, of course, the slides, a lot of reading. I will share the PDFs, etc. And there will also be the videos. Well, the videos, there will be a link. I will put them on YouTube. And so if you, as I said, if you have connection problems or whatever, you can access to the sessions. Make sure I mean, of course, you are not obliged to connect to the sessions, but make sure that at some point you couldn't make it. Make sure that you go to the videos and you see them, so that you will not lose some details or some things that we will discuss, particularly in the laboratory, because sometimes people ask about some specific aspect of some tool, and then you miss this. So this is important that you make sure. Okay, so in the lab, of course, we will produce code, essentially code. So I'm going to ask you if this is not, you do not already have such an environment to create an account in GitHub. Because the idea is that you will create a book like the, models and photographers and artists have their books where they show what they do. Okay, so you are computing systems engineers. What you do is programs and systems. So you need to have a book that you can show them, as you can show the world. Well, I did this, and I have programmed this, etc. So we will manage the code on GitHub. Okay? So please, if you do not have an account on GitHub, create an account, and then I will send my ID by mail. Please add me to the space that you devote to the course. Okay, so create a project on GitHub devoted to the laboratory, and then invite me there so that I can have a look at your solutions. Okay. Then I don't know if you're acquainted with this, but there are systems that manage code versions. They're called SVN. So if you have worked with such a thing, I mean, you can connect this with your GitHub. Okay, so I wouldn't be against that people do that, but really make sure that your GitHub space is maintained. I think I have a question. Let me open. No questions so far. Okay, so I also added a reference of what is the difference between JIT and SVN. So have a look. It's a very short blog entry where you have the comparison. So to make sure that this kind of jargon you manage, okay? This is, of course, for any person that deals with computing solutions. The person has to be sure that she or he understands what is code management, how to do it, and how to share it with the world. Okay. So that's code management. Then environments. Well, that we will go step by step with those, but the environments, we will essentially work with Microsoft Azure, particularly because it has a student trial. And it's very comfortable with respect to others because you do not have to make sure that you control the subscription, the credits, okay, that they are. Of course, you have to control them because you do not want to lose credits as a crazy person, but well, it's more controlled. We will eventually have a look to Amazon Web Services, which is the solution of Amazon. And then we will also use some services of Google Cloud. So this will be the environments that where we will be moving around. I know that the university has a contact with Huawei and with IBM. As soon as they provide me with information, I can have a look and see whether you can also profit from these agreements. But for the time being, I do not have any information about this. So we'll be moving around these three main vendors. I mean, they are really out there and they are very important. So this will give you the right overview of the thing, you know, of the cloud. Now, of course, we have to communicate a lot. The thing that is that we are a real developers team distributed in the world. So one thing that I find it very comfortable when I work with people that are not located in the same geographic location and I is Slack. So you have the link there. I also send it when I send the welcome message to you. So do not hesitate to go there. You can write anytime at any hour of your day. If I do not, I mean, if it's night and I'm sleeping, I will certainly wake up and see I completely connected on Slack all the time. Okay, so if you have specific questions or whatever, feel free to use it. Remember that there is a general channel where I will give information, but you can also contact me, I mean, point to point, okay? So there's, we can interact personally without making everyone aware of what we discuss. Okay, so Slack will be an important thing to do. Then you have certainly received an invitation to a Google group that I created. I used the UTLAB account. Now, I know that many people do not normally use the UTLAB accounts, but you have your own personal mails. What I am going to ask, I'm going to put the link on in some minutes on the chat, is that you give me your address that you read. So to be sure that when I write an email that people are reading the email and that you are getting the information and that I'm sure that I'm not writing to a black hole that you never read, okay? But anyway, the general address for the group is that one, and then I will certainly use it to give you information. Then there is a point-to-point address, which is here, and there I'm the only person that I'm reading. Okay, it's just to organize my emails. I receive a lot of emails, so I will be sure that when I receive an email in this address, it comes from students from both the laboratory and the theory course, and that I read it and I can react on it. Okay, so feel free anytime to send mails and Slacks and anything. There is no problem on that. Okay, if you have questions, I know that you have advising hours in the university. What we will do is it will be continuous. Okay, on Slack you can ask anytime. If you really need a special session, please ask for an appointment and I will make sure that we have a Zoom session so that we can interact for specific questions. No, what I'm going to do is I'm going to stop sharing this this slide because I want to show you the site of the course so that you can see what it looks like and what type of material is already there. So just give me a second. Well, first, I'm going to share the link here. So on the chat, you have the link to the site, okay? I'm also going to share the this is the Slack. And what I wanted to share too, but I'm not going to do it now. Okay, so those are the two things. So what I'm going to do is I'm going to share again my screen to show you the site and explain you a little bit how it looks like. So, you are having a look at all my desktop, and you see. Okay. So the site of the course, the public one, looks like this. In home, well, you have it works for the laboratory and for the theory course. I know that some of you are either in one and not in both, but well, there you have all the information. I mean, there's no harm to read and to have access to some material to anyone. Okay. So, well, the description of the course, you have the objective. So there are the objective, and there are two bunches of learning outcomes. Now, it is important. You will see, well, at least for the laboratory, there will not be exams. Okay, so it's a continuous evaluation control. And that is mainly done by yourself. Okay, what you have to do is have the control of your education in your hands. I will very often give you some control questions in order to make sure that you do not miss important things that you have to have in mind. Okay, so the idea is that I either through specific sessions, either through the specification of the exercise in many different ways, I will make sure that to point out the elements of the that you have to bear in mind. Okay, and you have to make sure that you know this, okay, and that you are able to do this. It's particularly the laboratory, it's all about abilities, okay? So it's important that if there's virtualization, you know how to prepare your virtual environment, and you know all the steps to be considered, all the variables to be to consider in order to create your virtual environment or your container or your specific solution for storage or whatever, okay? So there's no point of examining you. The thing is that you have to have, I mean, you have the problem and you manage to produce some result. That's the only thing that works for us, I mean, as engineers. So that will be the case. So at many different steps, I will remind you, are you able to do this? Are you sure that you can deal with this problem, with this challenge, etc.? Okay. So the learning outcomes are there just to point out what you have to expect as a result, okay, out of the course. What do you take home, okay, when you, or to life when you finish the course, okay? So they are there for that. then there's the content. The content is related to the theoretical course. I will not discuss it here, but anyway, the syllabus is always there. And then today we are on the lab, so the section of the site devoted to the lab, it's called hands-on lab. The syllabus is here. Okay, there you have many different explanations, etc. But the important thing is that you have the topics that we are going to touch. Anyway, I'm going to open it. Well, anyway, the description, you have the content that you already knew, because otherwise you couldn't have inscribed to the course the sequence. And then we have, we will discuss in a minute about the evaluation, okay? Then there's the diversity and inclusion statement with some links and my contact information. You also have the link to Slack and then the bibliography. Do not get anxious about the huge bibliography that we have. I will point out which are the readings. At some point, I will ask you to read, and I will tell you what to read, how to get, or I will even go through some parts of some. There are a lot of articles, okay? So that you profit from this bibliography, and it's not there just to fill in the form. So that's the hands-on lab, and then well, there's evaluation. You have the same bibliography here, and contact here. You have the point-to-point address that you can use in order to contact me by mail. You have the Google Groups. Be aware that the Google Groups is sending to all those that are inscribed in the group, in the course, an announcement. This, for example, if someone, if we are programming something and suddenly someone had a problem that she or he solved, for example, you can use the Google group address in order to say, hey guys, we had this problem, we solved it like that, and then we could continue working, things like that. Okay, and of course the Slack. So this is for the site, and then let's go to the evaluation story. So we have the evaluation. So there will be 3 important hands-on, okay, to deliver. We will discuss, particularly the first one, what is expected from for delivering a solution. Of course, there is you will deliver it in GitHub, so of course there will be a README possibility for anyone to use your solution, etc. So the right practices, the good practices, in order to deliver a solution by any professional engineer. Okay. So there will be 3 hands-on to deliver. One related to storage. So we will start from the bottom of the stack to the top. Okay, so we will start dealing with storage, and we will have a 2 or 3 hands-on on storage. That will be handed in around the 2nd week of February. Okay, then there will be a hands-on on data processing. So to play with parallel programming. This is, I mean, parallel programming, you can imagine it's a kind of challenging thing to do. So this is why it's 20% of the note and not 15 like the previous one. And then we will play DevOps. Okay, how do you configure a cloud environment in order to deploy your solution? So that will be the last week of April. Okay, so this will be the set of hands-on that you will have to hand in, and there you will receive a grade. Okay. And then in order to grab up everything together, I'm not sure if you are acquainted to Medium. Maybe you do, because when sometimes we look for technical information, there are many entries from Medium. Medium is a blog environment where people share experiences in many different topics. But with respect to computing, for example, someone that developed a solution for dealing with a NoSQL store, and the person writes all the steps that she or he adopted in order to develop a solution with examples, even with running examples, etc. Someone did something, an analytics on COVID, for example. So the person writes a blog entry where she or he writes all the steps that were developed in order to produce a solution, these kind of things, okay? So I will ask you either to write a Medium entry or to prepare a YouTube or a TikTok video where you will have to sell one of the applications that you developed, okay? For normal people, okay, not for engineers. And that will be in order to wrap up the laboratory in particular. Okay, I will share at some point, for example, when we will deal with storage, there is a nice YouTube, it's like a TikTok because people sing, but they build a story comparing relational databases with NoSQL solutions. And they sing, la, 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 and they say what is all about dealing with relational and NoSQL. Okay, so things, that kind of thing I will be asking for. Okay, so that's for evaluation. And then there is the aspect of diversity and inclusion. In many universities around the world today and in conferences, there is a movement, a very active movement around diversity and inclusion. And in many companies, in all the vendors and the important companies, computing companies, have their diversity and inclusion program. So I believe that it is a nice way in order, it's like the package of you as professionals in order to go to the world, okay? So diversity and inclusion goes beyond gender aspects. It has to do with, for example, me speaking English. I'm not an English native English speaking person, so of course I have accent, and maybe for some people listening to me, my accent is difficult to understand, and this is why I have the captions there in order to make sure that if someone has problems with the accent, with the sound, with the connection or whatever, she or he can read what I'm saying, okay? Of course, this is partial because if I really wanted to be inclusive, since you are Spanish speaking people, I would have to add some Spanish captions in order to make sure that I am inclusive. I will not do this because one of the exercises of the university is to promote that you are comfortable working and interacting in English, okay? But anyway, this would be an inclusive manner. Another aspect is, for example, making sure that my slides are readable to anyone. My slides are not inclusive, for example, because I didn't think about people having problems with colors, okay? But in general, well, it is an exercise that I try to do, and I will ask you to adopt when you prepare your some material that I will ask for. I will different moments when I will ask specific tasks to do, I will introduce you to diversity and inclusive writing and also inclusive presentations, okay? So that you have all the elements to, adopt what you can and want and leave what you don't, okay? But in me as a professor, I am making sure that you are aware of these aspects, and it will be then up to you to decide how much would you want to adopt out of this, okay? Which is also a diverse and inclusive action and behavior. So that was for methodology. I'm making sure that I do not that I respect time, but I still have some minutes. Okay. So this is the introduction to the laboratory. Now we have some moments to for questions. Do you have questions before we continue?
Just here, I have a question.
Yes, please.
It's about hands-on. It is a report. It's just that.
It will be in many different manners. It will be code. Essentially, it will be code together with something else. But it will be code shared on
Okay.
GitHub. Yeah, I mean, in the laboratory, of course, there will be some reports or something, but I'm interested in really having code that I can run and make sure that you did what was expected.
Okay, so it's more the result, the hands-on.
Yes. Yeah, I mean, the hands-on will be, you have an exercise, you have a description of the exercise, you have tasks to do, and then you deliver your code with some specifications and well, maybe a README or something that goes together with the code so that someone can use it.
Okay, thank you, teacher.
He or she, I mean, she or her, and you can call me by my name. And since we're talking in English, it won't be the difference if you, I mean, so, you know, you is you. But I'm a she or a her. And of course, if you want to adopt I mean, I don't know, an alias, a name, or whatever you feel comfortable with in order when I address you, please tell me.
So teacher, can we call you Genoveva?
Genoveva, yes.
Okay. Okay.
Yeah. Yes, I mean, we will be struggling with code a lot. We can, I mean, you can call me by my name. Other things, may I ask something? Regarding data management, how many courses have you had? I mean, fundamentals of database management systems, I suppose, and something else?
Hi. Yeah, we've had an introductory course on databases. We also had another course of advanced databases, and last semester we had a distributed systems course. And I think.
Okay. And in advanced databases, what does it mean, advanced?
Yeah, well, on the first course, we just like we studied like SQL and like basic operations, and in advanced it was like a little bit more complex, like building like systems that allow like transactions and like
Okay.
the integrity between data and things like that.
Okay. And no SQL systems? Have you had a course
No,
on that? No SQL,
no,
no.
we have not had a course on SQL.
Okay. And what about algorithms? Have you had, I mean, how many courses on algorithms have you had?
I'd say we had one course at the beginning of the career called Algorithms and Data Structures, and then we had a discrete mathematics course, which we also saw a lot of algorithms like graph theory and stuff.
Okay.
And a little bit, I'd say we saw some algorithms in our artificial intelligence course.
Right. And you know how to determine the complexity of the algorithms, things like that?
Yes, we saw that on our
Okay. And what about distributed algorithms? Like, you know, in operating systems with semaphores and concurrency control, things like that?
I think I don't know if my teammates remember better than me, but I think that we didn't see distributed algorithms on our.
Okay.
We did have our operating systems course, but I think that we didn't cover algorithms, distributed algorithms.
I mean, distributed algorithms. Okay. Okay. Yeah, so that I do not rely on these things and I start talking about out of the blue of things that you haven't had before. Okay. And virtualization, do you know the techniques?
No, I think we haven't seen any in any of our courses virtualization. I think.
Okay. Okay. Good. Okay, so I have my questions. Do you have some other questions before I use the last part of the session to introduce the content? Before I die, says. I won't die today. Okay, if there are no more questions, remember that you can ask on Slack if suddenly you have a question that comes up. So do not hesitate. And what I'm going to do is I'm going to start with the first part, so getting acquainted to the terms of cloud computing. Okay, so first of all, what we have to make sure is to understand is that the cloud is an architecture, a computing architecture, set of servers, set of CPUs, machines, etc. So it's an architecture. Okay, there is a technological vision of the cloud, which is, in fact, is an architectural model that enables on-demand network access to shared pool of virtualized computing resources. Okay, so you have the computing resources somewhere in the world. They are accessible through some kinds of network, can be several, and the solution gives you access through virtualization to these computing resources. Now, what is important to know is that in the cloud, even the network is part of the cloud. Okay, so all the stack, all the computing stack, or computing system stack, together with communication, is a resource in terms of the cloud. And what is the objective is to combine. I mean, it's like going to the shopping mall and I get 3 servers, 3 the hard disks with specific storage capacity. I have some cores with specific capacities, 10 cores, and then I with capacity to build a main memory of this kind of size, you know. So you have all the elements and then you put them together and you create a computing system. Okay, so that's the idea of the cloud from the technological point of view. And well, but there is more than that. Okay, the objective is to provision and release all these resources with the minimal management effort in order to provide them. Okay, so as transparent as possible. Okay, so that we can put everything together and build our computing solution. And thanks to what? Well, thanks to a design unit, which is called a service. A service meaning hardware or a software entity that is accessible through an application programming interface, an API. Okay. So whatever you can think about a TPU, a CPU, a GPU, your watch, your anything, any hardware is there, and it is viewed as a service, okay? And it goes beyond, because you can also think that an operating system is also a service. A cache manager is also a service. A DBMS is also a service. So anything is a service that is out there, available in the cloud with a description of its characteristics, and that you will go and pick up in order to build something. Now, how do I get access to it? Well, the market vision comes to complement the technological vision, is that as I said, it's a pay-per-use model. What does it mean? When you buy a computer, well, you pay for it. And then if you use it to write letters in Word or to program the most important application that you can imagine and that it's possible to implement on the computer, it doesn't matter. You already have paid for it. And I mean, if you don't use it, it's your problem. In the case of the cloud, the idea is to pay what you use. Okay, so the resources will, even if you choose the resources, if you use them a lot or in a certain percentage of the time, you will pay only for that what you use. Okay, and this is in general called the pay-as-you-go model. And this is a billing model. Okay, example of things that we do in not a pay-as-you-go model and that we are used to it. For example, your subscription to communication provider, the one that you use in order to connect your phones. For example, today they provide you with SMS, a number of SMS messages, but today almost no one uses SMS. It doesn't matter, it's there, it's included, and you pay for it even if you do not use your SMS. Calls, again, nobody calls today. I mean, you call with WhatsApp or whatever, so the infrastructure in order to make calls, it's not used or very fewly used, but still you pay for it, okay? And this is not very nice, but we accept it because there is not another option, okay? So in the cloud, it's the opposite. You will pay what you use. Now, so the idea is that you will have your applications. You remember this. No, applications, in fact, are processes when they run. Okay, so you will have a certain number of processes, and these processes will be running for a specific interval of time, no, minutes, hours, or whatever. So in terms of CPU cycles, you will pay for the cycles that you use in order to the process to run for a specific interval. Okay, so when you subscribe to the cloud, they will tell you, well, the CPU cycle of a CPU of these characteristics costs X cents of dollars. Okay, and then, well, you will estimate how many cycles do you need in order to run a process, and you will know how much does it cost to run your process. And how much do you have to pay? And if you need more or less, the cost will adapt. Okay. So as the slide says, billing is based on resource consumption. So CPU hours, volumes of data moved, and gigabytes of data stored. Okay, so it's not the same to store your data in a specific location, geographic location, rather than moving your data to another storage space in the same geographical location than changing location. Okay. So where does this hardware resides? Well, the hardware resides in what we call today a data center. So there are huge containers that you have all seen, I suppose, on TV or in other contexts. These are these huge containers that have a lot of servers there with storage, etc., and that are put together somewhere in the world and that provide all these resources. And they can, on Earth, Microsoft has, for example, in the water and the sea, they have deployed these containers, and so anyone can connect and use them. Okay, so they reside there, and then, well, you have your set of containers. So as I said, it's not the same moving your data within the same container, from a server within the same container, than to another container rather than in France, for example. Okay, so this reasoning is associated with the type of operations that you do and the cost that it implies. Okay, so as I said, you as a cloud user, I mean advanced user and an engineer, you have to make sure that all the decisions that you are going to make across the different levels of the stack of your application, you have to make sure of how they are organized, and in order to determine how much credits you are going to pay. So that's the market vision, but as you know, they are put together within the same principle of use. And of course, well, I'm talking about the data centers, but then there are people, for example, that have developed operating systems. So how much does it cost to have a specific operating system installed in the resources that I choose? And then how much does it cost to have, for example, a file system that integrates all the data that I'm going to deploy logically in the resources that I choose. So the file system will be also a resource, a software resource that will have its cost, etc. Okay, and you can move on to the different levels across the different levels of the stack. You understand what I mean from the stacks. System stack goes from the network to the hardware, then to the application level until the software. Okay. So this stack. So every level of the stack will be charged with specific cost, and you can choose. Okay, so that's the principle. But again, architecture that includes services that can be hardware or software, and that can be chosen in order to build a computing system solution. Now, the ambition when it was invented was to run across large collections of physically separate computers and free computation in front of a user. So the real ambition of the development of the cloud is to get rid of, well, of course, civilians, but also institutions, of having computing centers. Okay, having a computer center within an organization or an institution is a lot of cost in terms of the hardware you have, in terms of the maintenance of the hardware, in terms of the obsolescence of the hardware, and in terms of engineers that have to work within in order to manage all this and provide service to the users, okay, of the organization. So the idea is that the cloud offers the possibility to externalize your computing center and only connect to it and pay for it according to your requirements, okay? So that's the main idea. The second idea is that already when the cloud emerged, and even before, everyone knows that the energetic consumption of computers is huge, and particularly of computing centers. So the principle is that if we put together all the computing resources in one place or in specific places, we will not reproduce these little centers that consume a lot of energy. Everything will be shared and used in a more reasonable manner. Okay, so and eventually we will reduce the energetic cost of having computing centers anywhere, okay? Now, the idea then the cloud heralds a revolution which is comparable to the emergence of the PC. You are very, very young to remember this. You weren't even born, but the emergence of PC was a huge event. If you think, I did my studies at UDLAP, and I remember that suddenly, well, it was not me at the time. It was a member of my family who worked there, and at some point they used mainframes. Okay, the VAX. VAX was a mainframe installed at UDLAP, and well, people use them, and you have to reserve your time, some hours, in order to be able to use the computer and do your homework, etc. And then at some point, the library at UDLAP was full of PCs, of computers. No? So it was a revolution, because now you didn't have to reserve a computer, time in order to access the computer. Anyone could access a computer, and you could have the screen, and it was friendly. And the students were crazy about this. And, it was a huge event. So the same event is having the cloud. Okay, suddenly, well, you use already the cloud. For example, if you have Dropbox, if you have almost all the applications that you have in your devices are services from the cloud. So you get access to, for example, storage support on Dropbox with much more unlimited than what you have in your computer, and it's accessible anywhere, and it's a huge event. So this is a kind of event that happened in the cloud. So the on-demand aspect, the vast scale, possibility of at any time, any moment access to your resources is a huge thing to consider. So now we are acquainted with the cloud, and we do not realize this, but it was a huge event. Now, so I had already said this. I don't know why I repeated this, but again, so technical and economic vision. Oh yes. So the idea is that you have distributed computing resources. Now, of course, there is the internet. Okay, so on internet offered as services to multiple users. Okay. Used to have on-demand storage capacity and computing power without having physically related infrastructure. As I said, you externalize everything and you just access to it thanks to a network connection. And then a storage environment and execution resources elastic, involving several actors connected by the internet. So this elastic aspect is very important because it has to do with the way you use resources. I mean, if I'm a person that does not need much more than enough capacity in order to run Office, so what is the point of buying a computer with other capacities? I just have Office access and that's it, okay? And if suddenly I have other requirements, then it will grow. And when I stop having these requirements, it will get reduced, okay? So that's a very interesting thing to do. And of course, you are computing engineers. So you can imagine the challenge to have this as a service, okay? So here we are talking, you zoom in on the challenge of having some solution that grows and gets smaller as some requirements arrive. This is a huge challenge, okay? And so the idea is, of course, to figure out how is this possible? What are the strategies of resources allocation, of quality guarantee, dependable guarantees in order to make sure that this works correctly? Okay, because another aspect that is not stated here explicitly is that the cloud ensures a specific quality of service. The idea is normally today's clouds is 99.9% of availability of your resources. Okay, so all the time you have your resources available there. Can you imagine a system that ensures this? That the system is not running today. No, that doesn't exist. It runs all the time. Okay, so there's no Telmex shortage at some point. None of this. So what is the principle? Well, the principle, if we go in a very simplified point of view, I think I'm running out of time. No, so I'm going to stop and not talk about the principle of externalization because I have 4 minutes. I'm getting 4 minutes late. Anyway, so next time, out of this general view, we will see the principle, and I will certainly contact you during the week in order to create some accounts so that we can have a look and see what I'm saying in a real context, and then start, as I said, getting acquainted with the concepts. So you have 1 second to ask questions if you need me to say something. Otherwise, yes.
Yeah, I just want to make a quick question. I don't know if you said this before, but are you gonna provide us with your presentations, or should we?
Yes, everything. Yes. I will write a mail and I will write it on Slack. You will have the recordings of the sessions, the material, everything online.
Okay, via Slack, right? Thank you.
Yeah, and then, well, there's the site of the course. You will see that on Slack. And then in Slack, it's just, I mean, it's to interact and eventually to announce something or share things. Yeah.
Well, thank you so much.
You're welcome. Okay, so for those that are inscribed in the theoretical course, I will see you on Friday. Otherwise, stay tuned, and we will meet again on Thursday.
Thank you, Doctor. Have a nice day.
Have a nice day. Have a nice day.